Alright, so welcome to part B. Let's write the Fourier series of f in terms of sines and cosines. Remember, we got this from part A. So writing the Fourier series, remember that the formula is this. And let's just write out a couple terms and see what we notice. Okay, so for n equals 0, this is going to turn into 1 and this is going to turn to 0. So we kind of just have like, let's make a split in the middle, and then these will be positive ends and these will be negative ends. So that's because first zeroth term is 0. So let's just do this. Okay, so n equals 1. What do we get? We get 1 over I, because n is 1, n is odd, times sine, that's my bad, times cosine x plus I sine x. Okay, let's see what happens when it's negative. Negative 1, and is odd, so I'm going to get negative 1 over I, and cosine negative x plus I sine negative x. All right, and notice that we can simplify this to be, we can rewrite it to be this by just, simple unit circle observations, right? So cosine negative theta will be equal to cosine theta, sine negative theta is equal to negative sine theta. And notice that we can conveniently cancel these terms, but our sines will actually add. So we're going to have, from here, we have 2 times 1 over I sine times I sine x. Okay, that's pretty cool. Let's see if something similar happens to the next term. So if n is even, we have negative 1 over 2i cosine 2x plus I sine 2x. And then similarly, we will have negative 1 over negative 2i, which is just going to be positive 1 over 2i cosine negative 2x plus I sine negative 2x, which then is just equal to 1 over 2i cosine 2x minus I sine 2x. Notice these will cancel and these will add, but instead we're going to get 2 times negative 1 over 2i times I sine 2x. And if you keep on writing these terms out, you'll notice that because of how this piecewise is defined, for all our odd n, we're going to get something like 2 times 1 over in times I sine nx. And then n is odd. And then for even n, we're going to get 2 times 1 over negative in times I sine nx, and even. And when we write, so basically we will have all the cosines cancel, and we will have this really nice expression where we have the Fourier series. This is the Fourier series formula. This is just going to be equal to, notice that these i's also cancel, right? This is going to be equal to 2 times 1 sine nx, or 1 sine x, minus, because remember this will taking over the negatives and the positive, was when we add the corresponding negative end to the corresponding positive end, we get this whole expression, right? So we're just going to have 2 times 1 times sine x minus 1/2 sine 2x plus 1/3 sine 3x minus ... plus -1 to the n plus 1 over n sine nx plus ... That's going to be our Fourier series. Okay. Watch the next video. Stay tuned for Parsi.